So we're chapter 4, section 3, day 1. Trig functions on the unit circle, but we're not on the unit circle today. So the first part, there's two parts today. The first part is using any angle. So that means you don't know anything about the angle. So our angle is going to be theta because we don't have any information about it. What we do have is we're given a point, and it's right there. So we know a point, just like you've always plotted points, is an x value and a y value. So when you're given a point, you can plot the point. Step 1. And these are just like quick sketches. They don't have to be super exact. 1, 2, 3, 4. So I'm just going to count by 2s, make that my 8. 1, 2, 3, make that my -6. So then I have a point right here. So that's step 1. Plot the point. Okay, and then once we've plotted the point, then with the instructions, by the way, I guess I should say that, for this type of question would be to write the 6 trigonometric functions given the point 8, -6. So we're going to write sine, cosine, tangent, cosecant, secant, cotangent, all from the point 8, -6. So then once we've plotted the point, we're going to connect to x. That's my little phrase. Connect to x. Because that's the part everyone messes up, is that you have to go to the x-axis. So in this step, connect to x, what I'm meaning is to draw a line. Draw line from point to the x-axis. Every time. It always goes to the x-axis. So here's my point. X-axis is up there. So I will go to the x-axis. And then you need another line because we want a triangle, right? Draw line to origin. So we connect to x and we connect, oh, I missed it, to the origin over there. Pretend like that goes to the origin. I missed it. Your right angle is always going to be touching the x-axis. And then over here at the origin is where our theta is going to be. It's always going to be near the origin, between the radius and the x-axis, close to the origin. It has to be like that. Do not connect to y, because then everything's going to be wrong. It always has to connect to x. Connect to x. Okay. All right, so then step 3, now we have a triangle. Let's find the hypotenuse. Find hypotenuse. Okay, so we have a triangle. And we have 2 sides of the triangle already. We know the lengths of them because of our given point. It tells us that the x-axis side of the triangle is 8 units from the origin. So the length over here is 8. That's the x. X equals 8. And the vertical distance, the vertical component, is the y-axis is vertical. So the vertical part, y equals -6, because the negative tells us we went down from the origin, and the 6 told us we went 6 units in the down direction from the origin. And then, instead of calling it a hypotenuse, I'm going to switch my letters and call this the radius. R equals. So first let's find that value. We have 8 squared plus -6 squared equals r squared. So then 10 equals r. And I'm sparing you guys the calculating it because we all know how to do the Pythagorean theorem at this point. If not, then you have some serious problems ahead of you. All right, so r is 10. So we found that r equals 10. It is the radius. The radius of this circle. Like, what circle? There's no circle on there. Well, the radius is from the origin. This piece is the radius. So if we took the point side and we rotated around the same distance all the way around the circle, it would make a circle. And it tells us how big our circle will be. So on the unit circle, our radius is always 1 unit, because that means we don't have any information about the size of the triangle, so we're just going to do ratios. But since we have a point, we have information about the size of our circle, and it comes from these. The 8 and the -6 gives us a 10. So this radius is a measurement, a length measurement, so it's always going to be positive. It will never be negative, because it's telling us how big the circle is. And it's not going to be 0, because you can't have a radius length of 0, because then you don't have a circle. You would just have a point. You would just have a dot, not a circle. Okay? Step 4. Find the 6 functions. Find the 6 functions, or 6 trig functions, however you want to word that. So I'm going to go ahead and set it up as sine. Since we don't know the angle, it's sine theta equals, and then cosine theta equals, tangent theta equals, and then leave some space, because we're going to write some stuff in there, cosecant, secant, cotangent. So we set it up for our 6 trig functions. But before we finish this example problem, I'm going to give you a little, I guess you call it a chart or a table or something, that will work for all of these problems. Because so far we've been doing our trig with opposite, adjacent, hypotenuse, and now we've just changed it, right? Now instead of opposite, adjacent, hypotenuse, we're going to have a y, an x, and an r. And those are going to be more useful than naming the sides the way we have been. So let's start with sine theta. I'm going to write the 3 main ones. So we've been calling sine opposite over hypotenuse, and it is the same as what we have here, because if theta is between the x-axis and the origin, then the opposite side will always be over here, and it will always represent this vertical distance, which is a y distance. So we'll just call, instead of calling it opposite, we'll call it y, because it's always going to be a vertical space. And sine is opposite over hypotenuse, right? So opposite over hypotenuse. The hypotenuse is the radius of the circle. So r. So we can call it y over r. And then cosine. Cosine is adjacent. So from angle theta, the adjacent leg of the triangle will always be the x-axis. So the x distance. So x over hypotenuse, which we just named to be r. And then tangent is opposite over adjacent. So since we said opposite is y, and we called adjacent x, then it's y over x. So tangent is y over x, sine over cosine. All right, so then we're not quite done with this. Because I told you just a minute ago that the radius will always be a positive value and it will always be bigger than 0, we don't need to worry about anything in the denominators for sine and cosine, because they're the radius, which will be a positive value greater than 0. But in tangent, there's an x in the denominator. And it is possible to have an x value that's 0. That just means it doesn't go left or right, it would just go up or down. So if x is 0, and we put a 0 in the denominator, then we break one of the cardinal rules of math, is you cannot divide by 0. So we need a little extra rule here for tangent, that x may not equal 0. Because if x equals 0, then the tangent does not exist, or it's undefined. It's a more proper way of saying that. So that's just a little extra piece. Then we have sine gives us cosecant. Cosine gives us secant, because s and c make a pair. And then cotangent. So cosecant. If sine is y over r, then cosecant is r over y. So now, again, the radius isn't in the denominator, and x and y, sometimes they're 0. So we need the little extra note for this one also, that y cannot equal 0, because if it does, then the cosecant would be undefined. Secant theta. If cosine is x over r, then secant is r over x. And you probably guessed that x cannot equal 0 because it's in the denominator. And then last we have cotangent. That cotangent, tangent's y over x, then x over y, and y cannot equal 0. And that is your guide to doing all of these types of problems. I'm going to highlight it too because it's super important stuff. Okay, so now that we've redefined what sine, cosine, and tangent mean to us, and we have a triangle with our x, y, and r, we can fill in these functions. So sine theta. Well, I know sine theta is y over r. So if I look at my triangle,
teachers and students, please.
All right, so we have y over r. And from our triangle, we already defined y to be -6. And we defined r to be 10. -6 and 10, those are even numbers, both of them. So we know we can divide them by 2. So we get -3 over 5. So sine theta, for the point -6, sine theta is -3 over 5. If we have sine, then cosecant is pretty easy to find. You just flip it. So 5, we can put the negative on the outside. Doesn't really matter. -5 over 3. And then cosine, we just defined cosine to be x over r. And x in our drawing is 8. And r is 10. So we have 8 over 10, which is 4 over 5. So that means the secant value is 5 over 4. And then tangent, we said, was y over x over here. So the y value is -6. And the x value is 8. Those are even numbers, so -3 over 4. Cotangent, we flip it, so 4 over -3, or a negative on the outside, 4 over 3. And there's the first part. So that is when you're given a point. So you have ratios of side lengths. What you don't know is the angle. The second part is pretty much the opposite of that. So here, let's do that. So on part 2, we're going to evaluate trig functions of quadrantal angles. I'm just going to put quadrantal angles. And this is, we want to find the exact value. Which means no decimals. We're talking about fractions only. And quadrantal angles, we already talked about that word. It is when it's the angle in the terminal side of the angle ends on either the x or the y axis. So the first one is if you're given that theta equals pi over 2. The instructions are to find the 6 trig functions. So we know that. We're looking for sine. Instead of writing theta, we know what theta is. So sine of pi over 2. And cosine of pi over 2. And tangent of pi over 2. And then we'll do the others also. All right, so we know the angle, but we don't know anything about the sides. So we'll just say they're 1 unit in length, which is what you do on the unit circle. This is in radians. So I know I have 0 radians here at the initial side, because 0 is 0. And then I know that where pi is, 1 pi is halfway around the circle. So pi is right there. That's 1 pi. And you can just think of pi as what you're counting. So if there's one of them over here, that means if I go half that distance, I have half of a pi. And if you don't write the 1, then it's pi over 2. That's half of a pi. So this is half a pi. That's 1 pi. That makes this 1.5 pi. 1.5, written as a single fraction, would be 3 over 2. 3 over 2. But what are we counting? We're counting pi's. So 3 pi over 2. And then half again would be 4 pi, 2 pi. Sorry, 2 pi. Yeah, 4 pi over 2, which is 2 pi. All the way around the circle. So my angle is pi over 2. So from the terminal side, I go positive pi over 2. So the terminal side of my angle is right here. So I'll put a point right there. And then I need to find the value of that point. So my x, if I'm on the y-axis, that means I did not go left or right, any. So the x value is going to be 0. And that figure out, did I go up or down? Well, to get to the pi over 2, that's up at the top, so I had to go up a unit. So we're just going to put positive 1 for the y value. And I know the radius because it's 1 unit long. If you weren't sure about that, you could do Pythagorean theorem with the 0 and the 1. And you get 0 squared plus 1 squared equals r squared. And you solve it and you get the r equals 1. So on the unit circle, the radius is 1. So if I want sine of pi over 2, and I know sine is the y value over the radius, then it is 1 over 1. So the sine of pi over 2 is 1. Then cosine. Radius on the bottom. Cosine is x over r. My x value is 0. So this is going to be 0 over 1. 0 over 1. It's okay to have zeros in there as long as they're not in the denominator. 0 divided by 1 is 0. Your calculator will calculate that. What it won't calculate is 1 divided by 0. It'll tell you that's an error. But 0 divided by 1 is fine. It's just 0. And then tangent of pi over 2. Y over x. Y. Sine over cosine. Y over x. So I have 1 over 0. Oh, that's the one I said you can't do. So it is undefined. You cannot divide by 0. You can write undefined, or I do this backwards capital letter E and put a line through it that is no, does not exist. Or it's undefined. Kind of sort of basically mean the same thing. Okay, so now that I have those 3, I'm going to write my other 3. So the cosecant, sine and cosecant go together. Cosecant pi over 2. Well, if the sine is 1 over 1, then the cosecant is also 1 over 1, so it's 1. Cosine and secant go together. Secant pi over 2. Cosine is 0 over 1, so secant is 1 over 0. Uh-oh, we have a 0 in the denominator. So we're going to do the backwards capital letter E and then draw a line through it. Or you can write undefined. The book answers will tell you undefined. Same thing. And then cotangent, pi over 2. Can you have a cotangent if your tangent is undefined? Yeah, sure you can. I was just said it's tricky. 1 over 0. 0 over 1. Flip it. 0 divided by 1 is just 0. So we found all 6 of them. Okay. So try this one. You don't have to do all 6 of them. This is just a single one. Find the sine of negative 180 degrees. You can set it up before you even figure out values, because you know it's a sine, and sine is y over r. So I sketched the first one, so sketch it. There's the terminal side. Plot a point there. So 1 to the left and 0. And since we don't know anything about the lengths, we're on the unit circle. So you just sketch where the terminal side of the angle is, and then figure out if you put a point of a unit length 1, what would the xy coordinates be? And if you have those 3 pieces, you can write any of the functions. Let's do one more. Last one. Secant of 4 pi. Secant of 4 pi equals what? So before I told you whenever you have secant or cotangent, you would just flip it into the other one. It's original. Do the reciprocal of it. It's good to think about that, but now that we have this little chart, you can think secant with cosine, and I know cosine is x over r, so secant would be r over x. So we would have r over x. So now we know what secant looks like. And then just sketch to figure out what you're dealing with. 0. 4 pi is more than once around the circle, but that's okay. So that's 1 time around the circle in the positive direction. That gets me to 2 pi. And if I go around again, now I'm at 4 pi. So that's 4 pi. It's a coterminal angle with 2 pi. So the point, xy coordinate point, is the same for 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. As many times around the circle as you want to go. It's the same. The terminal side lands right there. So the xy's are the same. X, positive 1. Y, Well, I didn't go up or down, so it's 0. Secant is r over x. We know the radius is 1, and the x value we just found to be 1. So the secant of 4 pi is equal to 1. And that is all. All right, so your assignment is page 251, number 1 through 15 odd.
Pardon this interruption. We are about